You're going to start with Locust as your body with Locust.
Gracias. Buenos días. ¿Se escucha bien todo? ¿Sí? Perfecto. Primero quería decir que esta es mi primera conferencia en español y para un americano como yo que solo va a conferencias en inglés ha sido muy impresionante. Gracias a todos los organizadores y a ustedes también. Pero aunque hablo español y lo entiendo, sinceramente será un poco más fácil para mí presentar en inglés. So I'll be switching to English, if that's okay. ¿Qué te digo? No lo puedo negar que soy un yankee americano, so yeah. Good morning. So my name is Andy Almonte, and currently I am a team lead at Bloomberg Engineering. I lead a team of data scientists and software engineers in our machine learning London team. So of course, data science, software engineering, lots of Python. So before we dive into David's more interesting talk, I just want to talk to you guys a little bit about Python, Bloomberg, why we're here, and why we're actually committed to this language so much. So Bloomberg, so how many of you before this conference knew about this company? Good, yeah, you've seen that strange TV channel with all the fast-moving info and then all these strange people talking nonsense, right? Yes, yeah, that's us. But besides that, which is the news organization, we actually consider ourselves like a really large global technology company. And our main product is actually software that distributes and analyzes financial data for financial professionals. And this is a really large operation. So we're talking about 200 plus offices, 19,000 employees, and 5,000 in engineering, mainly in New York City, where I'm originally from, London, where I am now, and San Francisco. So London is our European headquarters, and this rendering that you see here is actually our new headquarters in the city of London. So right in the center in the city. I think we're down the block from the Bank of England. And that actual date on there that says 2018 is a little bit off. We're actually moving in a few weeks, it's expected. And yes, I can't leave a talk without telling you that we're always hiring. But besides that, Python. So Python actually, for all of the new development that we're doing at Bloomberg, it's one of 3 core languages. And besides the other 2 languages that you see here, I think it has a much more interesting story about how it started at our company. So unlike the other 2, it was not something that our infrastructure team decided, hey, we need to start using this language and we're going to build all this infrastructure around it. It was actually our client-facing application developers like me and David that some years ago, they started experimenting. They started a grassroots kind of movement to start integrating Python into our environment, and that was a huge success. Eventually, today, we have a Python infrastructure team that supports globally Python at our company. They're based out in San Francisco. We have what we call a Python guild. This is experts across the globe that come together to actually support the language, come up with best practices, and really just kind of guide how we're actually using the language within the company. And some of those people are actually here at this conference, so if you want to talk to them a bit more about what we're doing. So we're deeply committed. There's sponsorship that we're doing. We're hosting community meetups across the globe. We're contributing to open source. The last point there about Open Source Day, that's actually really interesting. This was a couple of years ago in New York City. We had a volunteer weekend event where developers came in and contributed code to Python open source. I was actually there for this. It was really, really great. So yep, I think that's enough from me. If you want to talk more about Python, Bloomberg, I'll be around today. If you're interested in even machine learning and what we do in that space as well, with Bloomberg, of course, there's a lot of that going on in Python. Feel free to grab me later. But I'm going to hand it over to David, who's going to talk to you about Python on his team, which supports what we call the worksheets product. Thank you.
Thank you, Andy. Thanks, everyone, for coming. First talk of Sunday morning. Everyone hangover. You're the true champions of PyCon. So yeah, I'm David, and I'm also a team lead at Bloomberg, and I'm going to talk about load testing your services with Locust.io. I've also created Kool-Aid, who's also a member of my team. He gave initially this talk internally, so yeah, this is based on that. So my team owns this product. It's basically a real-time market monitoring tool, part of the Bloomberg terminal. Financial professionals just list the securities like stocks and things like that that they're interested in, and real-time data comes flowing through. And it's a bit of like Excel meets Google Docs. It has like real-time collaborative editing and stuff like that. So we're in the process of releasing this application to all of our clients, right? And we asked ourselves this question: what is our capacity? It's like, oh my God, we don't know. So like, if you don't know the answer of these questions, you won't be able to sleep well at night, and you want to sleep well at night. So we need to start exploring our systems qualities, like, is our infrastructure adequately sized, or are our individual requests fast enough for our clients, or what's going to happen when we throw more load to our system? Is it going to scale well? What happens if it has too much load? Will it stay stable? So yeah, how can we assess these things? So I'm going to talk about like 3 different categories: performance testing, load testing, and stress testing. And then later on, I'll focus on load testing with Locust. So for performance testing, we want to just evaluate how the system performs. And it's not about heavy load, and it is about tuning. So we want to establish what the benchmark behavior is, so like how the system behaves with a normal, regular load of users. And it's not aimed to find defects. We have like integration testing and unit testing for that. Then moving on to load testing, here we want to feed the system the largest task it could possibly handle, and then just increase gradually that load until it just falls apart, right? We want to simulate sort of like real user behavior, so we have like virtual users. So the goal here is to expose certain system defects like buffer overflows or bad memory management, etc., that only happen with increased load, and also to figure out what our limits are. Like, are we hitting our database limits, or is the network maxed out? And finally, with stress testing, we intentionally want to break the system down by either overwhelming it or just taking away resources. So let's bring down a third-party service that we depend on, or let's bring down this database and see what happens. So the goal here is to make sure that the system recovers gracefully and can handle errors, and also to understand better how our application now behaves and how it should behave. If this maybe non-essential service crashes our application, that's pretty bad, right? So we needed to consider a few points before we start putting all of this in practice. Like, we must have monitoring tools. If we don't have monitoring and do a load test, then we don't know what we've achieved. And also, obviously, I mean, this may seem obvious, but if the service that you're trying to load test is not important enough, if it breaks, nothing happens, then why bother, right? And an important thing to consider is also that you can never get this 100% right. You cannot simulate all scenarios and user behavior perfectly. So it's about iterating. Also, to identify user behavior, you need to study how your users use your application and find these patterns. You also, before starting, you need to define what you want to achieve, right, in measurable terms. So do we want to support 1 million users at the same time, or do we want to accept 6,000 requests per minute and be fine? So we need to define these goals. And also, you have to isolate your testing environment. This is very important, so I have a slide just for that. You don't want to send all this load to your production environment, right? So you need to separate it. You don't want your users not being able to use your application just because you're doing some tests. And then we're just the metrics that we can measure, things like throughput, response time, error rate, what's our CPU like, and what we were spending the time on. So yeah, finally I'm going to introduce Locust. So Locust is an open source Python-based load testing tool. And it's really good because it allows you to define the user behavior in code in Python. And it's very easy to use, and it's based on coroutines and async code. So it's nice and scalable. If you cannot generate enough load for your set of machines, you can just throw more instances of Locust at it. And it's also battle tested. Not only we use it here at Bloomberg, but other companies like DICE, the video game developer, they use this for the backend services of Battlefield. So it's pretty good. It has two ways of using it. You can use the command line interface or the web interface. For the command line interface, you just install Locust and run it with no web arguments. And you can define your Locust, you can pass your Locust file, and that's where the user behavior lives. You can pass the number of users you want to simulate and at the rate at which those users will be spawned into the system and start sending requests. And then just the end parameter is just to say, I want to repeat this process 1,000 times, and I also want to print some stats. So Locust will do all of this, and once it's done, the process will finish, and you'll get your statistics. With a web interface, you can just say, you launch Locust, and then you can access it localhost or wherever you have it. You define the number of users you want to simulate, then you define your hatch rate, the rate at which the users are spawned. You click Start Swarming, and you get this nice web interface where you see all of your services, your requests, nice statistics about time, and then you can see failures, you can see exceptions. You see the number of running users over here, the requests per second, and the most important button, the stop button, in case things go south. That's always useful. So how can we define user behavior in Locust? So this is a very simple example. This is just sending load to a website. So we define a list of tasks in this website tasks class. And we can hook into the onStart signal. And here we just authenticate with our credentials, right? This is using an HTTP client. Locust comes with an HTTP client, so for most use cases, that's all you need. And that's what we're using here, right? And this website just has an index and an about page. So we use the task decorator to define what our tasks are. So in the index task, we just send a get request to the index, the same with the about task. Now, when we spawn a user with this task set, like we do here, it will pick just one of these tasks at random. But obviously, the index page will be loaded more frequently than the about page. So in that case, you can pass a parameter to the task decorator, sort of like a weighting, right? So if we say task 7 for index and task 3 for about, it's 70% will go to index, 30% will go to about. But what happens if your backend services don't talk in terms of HTTP? You can have TCP or your own crazy in-house protocol. So Locust allows you to define custom clients. So let's say that we have our custom protocol, it's all crazy. So we have our custom client class where we instantiate a client for this protocol, and we just wrap all the attributes with get attribute we get. Assuming the protocol client has a method for each request that we can send, we just wrap it here, and the wrapper will be in charge of measuring time. So Locust makes you measure the time of your request in the custom client, because you may do some validation after or some processing, and you don't want that to be considered part of it. So we try our request. If it succeeds, we just send a success event, and we send time information, what the request was, etc. And that way, Locust can display it on the nice web interface or the statistics. If we catch an exception that is specific to our protocol here, we just throw or fire a failure event, and we also include the exception. That's also useful for the dashboard. All right, so how do we deploy this? At Bloomberg, we use containers. We use Docker because it's lightweight. It was well suited for small tasks. It's very easy to deploy, and we could just like throw more instances at it. More specifically, our architecture looks a bit like this. So we have a Locust master instance, and that is in charge of coordinating all the slaves. We can throw more slaves at it. That's living in one cluster. It has a Redis instance. We use Redis just to share information across the slaves, like user IDs and things like that, so that they can send meaningful requests to our backend. And here, on the right-hand side, is our cluster. So the slaves will send the request over there, and then the slaves will report back to the master. Yeah, it's very important that the machines you said the load from are different from the machines receiving the load, because otherwise you will be consuming resources used to generate those requests, and that would be meaningless. So I have a demo over here, but I think if we want questions, I might as well just keep it. It's basically the dashboard in action. But I would like to talk about what happened when we first tried this in the monitors team. So it was quite embarrassing because we sent the load that we would have expected in a few months, and turned out that we were dropping lots of requests. And it was basically a single request taking too long, and it was filling up the queues of our load balancer. So that's pretty bad. If we hadn't used Locust to do this, or at least a load testing tool, that would have been an outage, right? So we had to fix the problem. We added more instrumentation. We realized there was a regression in a database query. So we fixed it, and we shipped it, and this is what happened after. So you see the average response time in milliseconds. Blue is development environment, green is beta, and yellow is production. Made the fix, brutally went down from like seconds to a few milliseconds. And you can see like the staged rollout. So that's a bit of a success story, basically. And things that we can do after this is automating, bringing up the whole environment, etc., like have it included in Jenkins, and things like that. But yeah, that's pretty much it. So thanks a lot. Thanks for coming so early. And you guys have any questions? Yeah. Do we have a microphone?
Yeah, thanks. Thanks for the talk. You talk about how maybe we can go beyond this using Jenkins and throw it at Jenkins. Can you elaborate a little more on how you can?
Yeah, so right now we're just manually bringing up Docker and bringing up the containers, and it's a bit of a manual process. And then the reporting, it just generates a CSV file. So one of the things that we can improve is basically having a Jenkins job that does this process for us, and also processes the CSV file and gives you like some nice dashboard maybe, and it can compare results from previous runs and things like that. So that's basically what I meant, automating the.
From your experience, is like a better idea to run it schedule, to have some periodic stat, or running before shipping chains or.
So it'd be quite nice. I mean, ideally, you could run it, I don't know, daily, or like if it takes a bit long, it's maybe not worth it to run it on every single pull request. But at least you would like, it would be good to have like a measurement over time, maybe daily, maybe weekly. It depends on the availability of the cluster you're sending the load from. If you cannot use it every day, then, but if you have it. Maybe like for pull requests, it would make the review process a bit longer, right? You want tests on pull requests to be fast, but yeah, you could do it daily.
And lastly, is the testing environment you are going to run the test to have to be a one-on-one copy of the production instances?
Yeah. Yeah, right, that's right. So we run it against our alpha environment, but the alpha machines are the same hardware as the production machines. We just have fewer of them. And yeah, it's pretty much the same software. It's the same set of packages. So yeah, it is a pretty, and in our case, we copy down the database from production. So we can use real data, and we use like Redis to pre-populate it with some random users. And then like, in our case, each slave would just like pick one of those users from Redis and say, start sending requests. That's pretty much it. Thanks.
Hi. I have one question. For those cases, well, like mine, where first you set up your development environment local in your machine, right? Like, is it worth testing using Locust in your machine before going to the staging server, or like does it add any value at all? But that's always what I wonder, because the latencies are always like lower. Of course, you don't have any connection delay, but
I think it's, I mean, you want to have some sort of testing environment before you enable users, right, and do load testing on that. So for us, that's our alpha environment, right? If we did that locally on our machines, I don't think it would be a representative sample, because we want to see that the load is distributed across all machines. Like if you test only against a single machine, then, I mean, yeah, you'll find some information, but it will not answer the question of what your capacity is. I guess, I mean, you can do all sorts of benchmarks, maybe at a lower level rather than a whole system level. And maybe that may be more worthwhile doing in like your own machine or something like that. Yeah.
And also another question. Well, no, I guess that answers. No, it's okay.
You can grab me later. It's fine.
Hi, it was approximately the same question, but I would like to focus on, I understand in Bloomberg you use it for system operations or tool. So I would like to know if do you integrate or do you use the tool during the development, if there is some use for that before passing to pre-production or to system operations?
I mean, so you can have a rather unstable development environment, because this is not only testing. I mean, you may make a request to one of our services, right? And that will send other requests to third-party services, right? If not every service is like super rock solid on your development environment, then that's not gonna work out very well. But we ship to alpha immediately after dev, right? So like the feedback cycle is pretty quick. Like the fix that I was talking about, like it happened within the same day. We were like, oh my god, it's terrible, and figured out in the same day, fixed it, and then ran the tests again. So yeah, still, I don't know if that answers your question, but
yeah, sure, perfect.
More or less.
Thank you.
Right.
So we have time for one more question, if it's the case. No more? Yeah.
Since there's another question, a quick question which is a bit out of topic. What's your feeling about working in London? I understand you're a European national.
Sorry, there was a bit of noise. Can you say that again?
Working in the UK post or in the run-up to the Brexit.
You're asking about like working in the UK in general, or?
I mean, for someone who's a non-UK citizen, I presume.
I'm from Cádiz, so.
And for exactly,
you can
so,
answer that as
so
well.
since I'm the non-EU citizen, non-UK, so yeah, I mean, we do get a lot of questions about Brexit and what's going to happen, but the company is very, very much committed to London. I think that's for sure. I think our senior management has said that as well.
We just built a new office. So.
Yeah, we just built a new office. We're not going anywhere. And just personally, I've been in London for about 3 years. I like it a lot. New York is still home, but London is very, very nice. And yeah, in terms of Brexit, let's just let the politicians figure it out, and we'll see where we go from there. But I think there's certainly not much is going to change in terms of our commitment to London and being there. Yeah.
Okay, so if there's no more question, there's no more time anyway. So give a big hand to Andy.
Thank you.
David, please.